Hi, I'm Priyanka Vergadia, and this is AI Simplified, where we learn to make our data useful. In this series, we've been learning about ingesting data, training models, and getting predictions. It would be handy to learn how to automate all of these tasks by implementing them programmatically. In this video, we will learn how to do exactly that with the Vertex AI SDK. Now, before we dive into the SDK, let's take a quick look at the options to interact with Vertex AI. There is Google Cloud Console. It is the UI to work with our model assets, the data sets, the endpoints, and the predictions in cloud. Now, so far, we've been using the console in this series, so you must be familiar. But if not, I've included the links to the previous episode below. Now, anything that you can do through the UI, you can also do programmatically. And for that, we have the Google Cloud Vertex AI SDK. And then there are Vertex AI client libraries, which help us make calls to the Vertex AI API. Now, the benefits of using client library is that they are optimized for languages that you choose to use. For example, Java, Python, or Node. Now, the question becomes when to use the console and when to use the SDK. The UI helps us get familiar with the features and functions available in Vertex AI. So for that reason, using the UI is my go-to recommendations if you are new to machine learning and AI or just prefer to do things visually. The SDK is best if you're looking to programmatically implement the steps in your ML workflow. Now, if you are an experienced machine learning engineer or data scientist, then you would benefit from the ease of automating your workflow. If SDK isn't available in the language of your choice, then you can use the client libraries or the REST API. Now that we know the different ways to interact with Vertex AI, we need a fun example to play with and create a model using the SDK. I've picked out the perfect dataset for this. Beans! Well, who does not like beans? Being a math nerd, I found out that Pythagoras, the one who came up with a square plus b square equals c square, that Pythagoras had an aversion to beans. Who would have thought, right? Okay, so here's the game plan. Overall, we will get the data, explore it a little bit, then create a model and deploy it to an endpoint from which we can make predictions. And we will do all of this using the SDK. We will need the tools to explore the data and prototype this ML model. Now for this, we will use notebooks within Vertex, which is hosted Jupyter Lab notebooks. They come pre-installed with your favorite machine learning workflows such as TensorFlow or PyTorch. These frameworks are already installed, and you also have customized hardware, so you can use the CPUs and the GPUs if you need it. It also integrates with Git, so we can customize and initialize a Git repo within the notebook, and it also integrates with other Google Cloud services. So we'll put our data into BigQuery, which is Google Cloud Enterprise Data Warehouse, and inside the notebook, we will download that data from BigQuery and then put it into use to explore that data using Pandas data frame. And then the next step would be to create our training job, creating the Vertex AI model, deploying it, and then making predictions, and then finally monitoring that job in the console. Now, ready to go? Let's see it. Now, in the Vertex AI console, we can create a hosted Jupyter notebook. And if we click on the new instance, we see that there are different types of notebooks that we can choose from. They come pre-installed with our favorite machine learning frameworks, and we can add GPUs if needed, and can also install additional libraries after the notebook is created. I've already created a notebook here, so let's get into it. The first step is to download our data. I'm using DryBeans dataset from UCI, which I have linked below. This is a tabular dataset that was taken from images for different types of beans, and different data points were collected on each type of bean. In manufacturing and other industries, it's common to extract tabular metadata from images and use that to train a model. I've already uploaded the data in BigQuery, and we can see the different data points in the schema. The label that we are predicting is called class, and we can run this quick query in the dataset to see roughly what the distribution of bean type is across our dataset. So here, I'm using the BigQuery client library to download that data inside my notebook as pandas data frame. And using this pandas method, we can see a plot of how the data is distributed by parameters. Next, we use the Seaborn library to create a pair plot which can help us identify our relationships between the features in our data and the label column within the class. Now that we have a good idea of what our data looks like and how it is balanced, we are ready to kick off the training job in Vertex AI. We initialize the project that we want to use. Then to train this model using AutoML, we first need a dataset. We can pass the URL to the data in BigQuery directly to Vertex AI. There's no need to manually move our data. Vertex will handle that for us. Now, if we go in Vertex AI console into our dataset, we can see our created dataset here, and then we can see more details such as the schema and the data source in BigQuery. We could kick off the training job here, but I trust that you can click a button. So let's stick to the SDK for this one. Back in our notebook, here is the code to create the training job. This is a classification model where we are classifying the beans into 7 classes. So we define that and pass all the different features that we want to use in the training this model. You could add more options here, such as how you would want AutoML to optimize the training. Specifically useful for an imbalanced dataset, I'm not doing that here. Finally, job.run will run the training job. We specify the dataset we want to use, the target column or label that we are predicting, how long we want to run the training for, and enable early stopping so Vertex AI stops the training if it does not see that the model can be further improved. Now you specify this, which is useful to keep the cost low. Once the model has trained, this could take some time. We can see in the console that the training job has finished. And we can see the evaluation metrics to see how our model actually performed. The confusion matrix shows how good a job our model did in distinguishing the different bean types. Since this is a tabular model, Vertex AI also gives us feature importance out of the box with AutoML. We can see the features in our dataset that signaled our model's prediction the most. Here it looks like shape and eccentricity were the most important features. Now that we have our model created, let's deploy our endpoint so we can use it to serve predictions. You can do that right here in the UI, but let me show you how to do that in the SDK. All you have to do to deploy the model is model.deploy and the type of machine type you want to use. There are more things you can specify here, but I'm just going with the minimum. Once created, we can see it in the console and test to make predictions from our endpoint. Let's head back over into our notebook and see how to make predictions using the API. We provide a test set, then we need to create the endpoint object, grab the resource name from the deployed model and use it here, and then we use that to make a prediction request to our endpoint. And there's our prediction. We just trained an AutoML model and made prediction using the SDK. We could use the same dataset to train a custom model too, all using the SDK. Here are the code samples that can help you do that. Try it out yourself, and if you need help, refer to the links below. All right, so today we created a bean classification model using the Vertex AI Python SDK. Give this a try yourself and let me know how it goes in the comments below.